Hi, I'm Christoph Pettis. I'm the CEO and lead consultant of PostgreSQL Experts. We're a boutique Postgres consultancy based in Alameda, California. I'd like to thank you for taking the time to watch this talk, and to the staff and program committee of Postgres Build for having me here. So today we're going to talk about hosted PostgreSQL. And what is that? Well, that's what this talk is about, but specifically we're going to talk about three products: Amazon RDS for PostgreSQL, Azure Database for PostgreSQL, and Google Cloud SQL for PostgreSQL. There are many other hosted solutions out there. The fact that we're not talking about those solutions shouldn't be taken as a negative on them. Just these are largely the market leaders, and they're the closest to community PostgreSQL. Here are some examples of other products. They're all fine products. We're going to skip over them either because they're new, such as Crunchy Cloud, and I haven't had a chance to really evaluate them. Heroku, it's a very locked down environment, same for Aptable. And the others are forks of community PostgreSQL and have their own special use cases and considerations. Other topics that we won't talk about as we compare these products are pricing. Pricing is just, there are too many variables, although as a rough guideline, the services we're going to talk about cost about 30% more than an equivalent bare instance. So yeah, that's a guideline you can use. We won't really evaluate GUI quality in depth. I'll give some quick impressions of it, but I'm not a user experience or human factors expert, so take my advice as just my one-off opinion. And we won't talk about comparative support quality between them. There's just too much noise in the data on those. It depends on what kind of tickets you get, what kind of issues you see, what kind of relationship you have with the vendor, all kinds of things. So what are these products? They're a locked box, like this one, that exposes port 5432. They all provide a database service using the standard PostgreSQL protocol. They run the community version of PostgreSQL with fairly minor patches, if any, in fact, generally just wrappers around the community edition. They run in a sealed environment, so you don't get shell access to the instance that they run on. There's no PostgreSQL super user access. There's no extensions with system access. They're built on a lockdown virtual machine and NAS storage. Most Google and RDS use Linux. Azure uses Windows, but none of them expose the underlying operating system, so you only kind of need to know what OS it's running. And all of the controls and configurations are through a web GUI, a command line interface, and an API. Usually the command line interface is built on top of the API. They all handle database backups and high availability for you, and in fact, that's their unique selling point. That's what makes them valuable. They all have the same set of general limitations. You can't install your own extensions. You only get a particular set of extensions that the vendor has approved for this particular product. For example, pgpartman doesn't run on any of them currently, which is a shame because it's a very valuable extension for managing partition tables. You don't get a true PostgreSQL super user account. You do get a highly privileged account, but it's not a true PostgreSQL super user. They tend to lag behind the community PostgreSQL edition by 1 to 2 minor versions, depending on the release cycles. And new major versions can take an extended period to be released, often a month, 2 months, 3 months. They all run on highly shared infrastructure that's completely out of your control. It's the vendor manages it, you don't get any say in it. And like all shared infrastructure, they can be over-provisioned and have mysterious outages and slowdowns. Okay, first product, Amazon RDS for PostgreSQL. This is kind of the one to beat. It's been around for a long time. It was introduced in 2013 for PostgreSQL. RDS as a brand name predates that. It was the popularization of the PostgreSQL as a general database as a server concept. It put that on people's radar. It's built on top of standard EC2 instances using EBS storage, same infrastructure as you get running just general compute instances on Amazon. There's no local storage. Everything is on EBS, on the network attached storage. It's by far the market leader, and one of the downsides of it being the market leader is we know more bad stuff about it than all the others. This is kind of not fair to it because it's just been pounded on more by everybody, but here it is. So what can you get in terms of a database? Well, your database can be up to 16 terabytes. That's the maximum size of an EBS volume. The largest instance you can currently get is an R5 24X, which is 96 execution units and 384 gigabytes of main memory. Pretty capacious machine. All your storage is on the EBS mount, and you could get up to 80,000 provisioned IOPS of maximum performance. So that's the fastest it'll go. And, like other vendors, Amazon measures bandwidth by number of I/O operations per second you can perform to the underlying service. It has a very comprehensive API and set of matching tools, lots of Terraform support, as well as Ansible and other automation tools. The GUI allows pretty much all the common operations without too much fuss. In my opinion, it's a fairly old style of interface. You end up clicking and doing a lot of page reloads to do pretty basic operations. You click around the UI a lot on Amazon. You get a parameter groups, which are basically sets of PostgreSQL parameters, and nearly everything, with some very, very small exceptions, is exposed to you and configurable. This is the closest to community PostgreSQL in terms of configurability. It does have a very weird and quirky interface. You need to understand what underlying units PostgreSQL uses. For example, the underlying unit for most memory allocation in PostgreSQL is 8 kilobytes. So you have to say, I want 5,000 of those 8 kilobyte units rather than just saying, I want 128 megabytes or some other number. For example, workmem is measured in 8 kilobytes. Booleans are listed as ones and zeros rather than on and off and true false. So that's a little annoying. Parameter groups can be shared between instances. You can set up one parameter group and apply it to a bunch of instances. And that's very, very handy if you're running a large fleet of database servers. And what makes that even more useful is you can calculate parameter values using expressions based on instance configuration. For example, you can set shared memory based on the instance memory. Community PostgreSQL should have this. This is very, very useful. One thing to be aware of is when you upgrade to a new major version, you don't get your parameters automatically propagated forward, and the underlying units in Postgres can change between major versions, so be careful. Access control is not based on pghd.conf. It doesn't really use it. It's all based around AWS security groups and IAMs, which is not bad because it's integrated to the whole AWS IAM infrastructure, which means provisioning new users is relative and tearing down old ones is relatively straightforward. Instances can have a public IP, a private IP, or both. So depending on whether that's in a VPC, all that kind of thing. RDS has lots and lots of graphs. They have CloudWatch and enhanced monitoring. They're pretty accurate, although the resolution is sometimes a little bit odd, and sometimes the data seems to be not quite on. All the major monitoring services can monitor RDS. Datadog and Vivid Cortex and Legato, anything you have, you can set up to monitor RDS. RDS has a tool, Performance Insights. It's a proprietary wrapper, graphical wrapper around pgstat activity and pgstat statements. It's very, very handy for a quick go-to, what's my instance doing and why is it slow kind of operation. Very handy. And you get a web interface around top. Yeah, I guess, sure. So backups. RDS can do both scheduled and on-demand backups. That's great. It has internal tooling that really resembles Wall-E. It might actually be a fork of Wall-E for backups. It can do point-in-time recovery with 5-minute granularity, which is usually fine. Upgrades use PG Upgrade under the hood, and there's no question about this because you can see the PG Upgrade log output. You can do it as a push button from the GUI, either scheduled or immediate. Upgrades can fail, especially with databases that have been brought forward from earlier versions because of incompatible extensions, or PostGIS is very common in this regard, or things like that. And sometimes if it fails, you need to use the CLI to get the actual failure reason. You have to suck a file out of the instance to look at it, which is a little tedious. High availability on RDS is built around a shadow replica that runs in a different availability zone. It's not streaming replication. It's some kind of block level replication between EBS mounts. You have to pay for it, but it can't take query traffic. It just sits there waiting to take over. The failure is DNS based. When the unit fails, it keeps the same DNS name, and the DNS name is just re-resolved to the new IP. Not bad. And using the standard tools, you can spin up replicas and promote them to primary is very convenient. And replicas can be in a different region than the primary. That's nice. RDS has logs. Yeah. You can use the API to download them, and it's really slow. Or you could use the web interface, which involves navigating to one, finding it, click a radio button, click another button, opening it, and then right-click to download. That's not great. And unfortunately, log format rotation and retention are not configurable, and so if you need to find an event that was 25 days ago, you're out of luck. The logs have expired. And you can turn on CSV logging, but then you go get both standard format and CSV output, and they both write to your EBS volume, so that takes your I/O bandwidth to the database volume to write the logs. And because of that, if you turn up the logging too high, it's very easy to choke your database with that. So that's a danger on RDS. Yeah, unfortunately, logging is not RDS's strong point. RDS, like all products, have some quirks and some good stuff. It has the richest set of PostgreSQL features compared to the Community Edition. So it's the most like Community PostgreSQL. Logging, unfortunately, is a mess. The parameter group UI is really user hostile because of the units having to search for parameters. It's not a great interface. And this is not theoretic. Real actual large companies' sites have been brought down by it because the user interface was so cryptic, they set the parameters incorrectly. RDS also forces an instance restart for parameter changes that don't technically require an instance restart, so just be prepared for that. And RDS databases tend to run hot. That is often because they have a lot of memory, so there's just a lot more caching, so not a lot of I/O to break up the CPU load, but they do tend to run hot compared to Community PostgreSQL. And there are strange things that we only see on RDS, like lots of lightweight lock pileups. Some of these are related to I/O capacity issues or EBS lockups, but we see a lot more lightweight lock pileups on RDS than on any other system, including Community PostgreSQL. So that's interesting. Still diagnosing why that's true. Okay, moving on to Azure Database for PostgreSQL. Microsoft joined the party, yay. It introduced this for PostgreSQL in 2017. It runs in the general Azure Compute Cloud environment, which is a nice environment. You can get database sizes up to 16 terabytes, up to 64 execution units. The amount of memory you get is based on the number of execution units, so 5 gigabytes per execution unit. This does mean that you can't really get small CPU count, high memory instances if that's what you wanted. It measures bandwidth in IOPS too, maximum is 20,000. And the connections are automatically limited depending on instance size. You don't set max connections yourself. It calculates it for you. But the connection limits it calculates will be fine. It has a built-in period of backup retention for 35 days. So that's what you get. It has a very comprehensive API. The Terraform and Ansible support is pretty basic, but it's usable. You can do what you need to do with it. The GUI is modern and clean and generally pretty well laid out. You do have to navigate around it a lot to set up other services, like create this service, attach it to this service kind of stuff, more so than you do on RDS. The configuration is a typical web interface. The UI is friendlier. It has on-off buttons, enum drop-downs, a little more modern. It still doesn't support PostgreSQL-style units, though, so you have to be careful that you're setting everything right. In a kind of wonky interface, it does include parameter descriptions, but you do have the parameter descriptions there. That's nice. A surprising number of parameters are not changeable, and the site suggests you kind of do a fan vote on the support forum to get them supported, which is an interesting way of designing a technical product. Azure's access control is a combination of firewall and pghpa.conf. Confusingly, in the documentation, pga.conf is called a firewall, which it isn't, but okay. You can have both public and private IPs. Great. It has a very comprehensive set of graphs and alerts within the application. It has a proprietary query analysis tool that seems pretty reasonable. It has a performance recommendation tools that offers tuning suggestions. Most of the ones that it comes up with are kind of trivial, but sometimes they're useful, and the good news is at least they're harmless. Backups happen automatically without configuration, which is really nice. You just get backups as part of your instance. It has its own internal tooling for backups, which includes incremental backups and snapshots for large volumes. Very nice. Can do point-in-time recovery with 5-minute granularity. Great. Upgrades are done using, major version upgrades are done using pgdump. Really. This is very unfortunate because it effectively will block a major version upgrade for a large database, because if you have a 12 terabyte database, you cannot do a pgdump restore. You'll be down forever to do a major version upgrade. High availability in replicas. HA is done automatically and does not need to be configured. It just happens. Very nice. If a node fails, the storage volume is attached to the new node, and standard Postgres crash recovery handles any inconsistencies or replays the wall. All the failover is IP-based. There's a front-end gateway that routes the current node, so you keep the same IP. You don't even have to re-resolve the DNS name. You can spin up replicas from the standard tools, promote them to primaries. That's all great. And a replica can be in a different location, Amazon's term for a region, than the primary. Logging is better than RDS's interface. That's not a high bar to jump over. The log format and retention are not configurable, so it keeps up to 7 days of logs. Logs are stored in instance storage, and you only get a gigabyte worth. Generally, what you're going to do is feed them into Azure's general logging infrastructure for analysis or retention. So if you're just running a Postgres instance and not much else, and you just want to do logs, that's not a great situation. You really want to plug into Azure's general logging infrastructure. It provides HA without special change or configuration. That's great. You just get it. You have a lot of detail and control over your environment, but there is a lot of clicking around. You have to create this and create that and then attach it to this, and no, you have to do that to do what seem to be relatively simple tasks, like assign a public IP. There are lots of restrictions on parameter settings, and I'm not sure about this fan vote thing. Also, this is in preview, pops up a lot. It's a new product. They're still working on it. And lastly, there's no logical replication either in or out, which is really a shame. That's a very valuable feature in Postgres, and I wish they supported it. A last little quirk is if you don't create a public IP address, you just use a private IP address, excuse me, you just use a public IP address, it runs over the public internet, not Azure's backbone, which is really bandwidth constraining. So that's strange and unfortunate. Okay, moving on. Google Cloud SQL for PostgreSQL. Not to be left behind, Google introduced Google Cloud SQL for PostgreSQL in 2019. It's still very new. It's part of the general Google Compute Cloud environment, which is very nice. So it's a very nice environment to run in. Google's made tremendous progress being a general hosting provider. You can have up to 30 terabytes of database, which is nice. 96 execution units and 639 gigabytes of main memory. Wow. Lots of I/O. 30K write IOPS, 100K read IOPS. This is set automatically depending on the storage type. This isn't something you provision the way you do with, say, RDS and EBS. And you can pick cores and memory independently. So you can have low memory but lots of cores for that kind of environment, or lots of memory, not many cores, if that's a more reasonable configuration. So that's nice. It has a very comprehensive API. The Terraform and Ansible support is good. It gets the job done. The GUI is very modern and generally well laid out. If you're familiar with Google's developer tools, it'll seem completely familiar to you. It's probably the best of the GUIs for all the various services we've looked at. For some reason, Google calls PostgreSQL parameters flags. I guess that's a Googleism. Sure. You go to edit, and then there's a searchable dropdown with all the editable parameters in it, which is a dropdown. Given how many parameters Postgres has, that's not so great. But it's easy to see the ones you've overridden because it just gives you a list. And it has the mystery units problem that they all have, unfortunately. But we get a ESO for Booleans, so yay. Many of the parameters are missing and some are in beta, whatever that means for a parameter. Maybe just if you set it, don't come crying to us if it doesn't work, I guess. If the instance is not in a VPC, you get a public IP address automatically. This is nice because you don't have to get quite the complicated assignment thing that you do in other services. You have to whitelist the public IPs that are going to connect to it. Otherwise, you have to create a separate public IP and assign it to the instance. Public IP is a separate resource there. Google firewalling is very strict, even within VPCs. Hosts generally cannot talk to each other automatically unless you whitelist them. This is complicated. No PGHBA.conf, The firewalling is how you control access. Google's monitoring tools are just okay. They're nothing special. This is an area that Google could really use some work on. Scheduled and manual backups. Backups appear to be disk image snapshots. When this was introduced, they didn't have PITR, and this was a huge limitation and made it hard to recommend this product. They've introduced that, so yay, problem solved. Upgrades are done with pgdump. And somehow they've managed to make this problem even more complicated and fiddly than just running pgdump. This is really unfortunate and really needs to be fixed. HA and replicas. HA is based on having a standby, not queryable, alternate node. You pay for it. It's just sitting there. Failover is done by switching the IP to the new primary. Okay, nice. The shared disk is moved to the new primary and crash recovery does its thing. And you could create replicas from the standard tooling. It's pretty normal. Logging is broken. You can download the last couple hundred entries and that's that. What they really insist that you do is use an external log collection service like Stackdriver. Probably if you're bought into the whole Google Compute Cloud infrastructure, you're using Stackdriver anyway. But if you're just running this as a standalone service, the logging is really a mess. Some other quirks and goodies. The instance config is very flexible. That's very nice. That's a general characteristic of Google's compute environment. CSV import and export is not supported, which is just weird. Just-in-time compilation is not supported, which is odd. Logical replication, really unfortunate. The product still feels rough. You bump into a lot of things that aren't implemented yet or are still in preview. And some really odd things, like setting checkpoint timeout too high causes backups to stop working silently, which is really not great. And this is beta pops up a lot as you're exploring the product. So which one should you use? Well, probably what you're going to do is use the one that your compute engines are in, because it doesn't make sense really to have a multi-cloud environment where you're running all your application servers in one cloud and your database in another and dragging all the data over the public internet. But if you're picking one just for PostgreSQL functionality, RDS is the most mature and PostgreSQL-like. It comes closest to community PostgreSQL, exposes most of the features. Google still has some rough edges, but if you're in the GCP environment, now it's usable. And Azure is somewhere in between them. Azure is moving up very fast. There's a lot of work being done on that product. They're all still evolving. In 6 months, the situation is going to be completely different. And of course, the big question, though, is why do you want to use a hosted environment? People say things like, well, you can scale out indefinitely. You never have to worry about backups. We take care of the database management for you. We provide, 9% of uptime. We're being threatened by the vendor. Who knows? The problem is this is all wrong. You still, even in a hosted solution, have to tune the database engine, tune your queries, set up and configure and provide HA for pooling. If you're using pooling like PG Bouncer, monitor, respond to resource issues, process logs and look for errors, design your schema, confirm your database and backup and disaster recovery strategy, do capacity planning. Hosted solutions really only solve 20% of the problem of running a database server, and it's up to you to handle the other 80%. And unfortunately, the typical support experience is you'll say, our database engine has caught fire, and they'll send you a link about tuning AutoVacuum. PostgreSQL people are not common. And high degrees of PostgreSQL expertise are not universal. And unfortunately, a lot of the tier 1 support people are just not well trained in supporting PostgreSQL. That being said, over 50% of our clients are on a hosted solution. It's very popular, very common. But why are they? There are 2 reasons. Failover orchestration and infrastructure as a code support. So let's talk a little bit about those. And these are not trivial. Getting all of the moving pieces for proper failover orchestration is hard. You have to detect and terminate the failed machine, pick the failover candidate, promote the candidate, and reassign the endpoint, attach the secondaries, reprovision the failed instance, and handle all the problems that can come here. Errors, split brain, all kinds of stuff. And this isn't simple on community PostgreSQL. The other one is infrastructure as code. And this is underappreciated advantage of hosted environments. Hosted database instances are a single resource. When you say when you run Terraform to say create a database instance, you just say create one of these database instances. There's no fooling around and having to create a ton of other services. It's reasonably easy to spin up and configure using Terraform, Ansible, all that stuff. Because PostgreSQL servers running on VMs are complex services, there's a lot of different parts you have to attach. And it can require a lot of fiddly Ansible to set up, configure, attach replicas. And infrastructure as a code is a highly desirable goal. Companies should do this. The problem is, on a host environment, you lose insight into instance performance because you don't have access to the underlying hardware to see what's going on. A lot of flexibility in configuration, like if you want to use high-speed local disks instead of a network-attached storage, you can't on the current set of hosted solutions. You don't get a true Postgres super user, and you kind of don't miss it till it's gone. It's amazing how useful it could be. And you miss some extensions like pgpartman. You also lose pretty much all programming languages, embedded programming languages, except PL/PG/SQL, PL/Python-U, things like that. And lagging on versions can be a problem. If you need a bug fix right away that's in a new version, or you want to upgrade to a new major version, you have to wait till the vendor's ready to provide it to you. You can come close to a hosted solution on community PostgreSQL. You can use a product like Patroni, an open source project, to manage your cluster, PG Backrest or Barman for backups, and then you have Terraform and Ansible for configuration management and distribution. You can use whatever compute cloud you like, or even a hybrid. Nothing says you can't run your own hosted environment on your whatever compute cloud environment or environments you're attached to. This does require a non-trivial amount of setup and tooling. There's no out-of-the-box solution that will just solve the problem for you the way there is on a hosted solution. That's a shame. The good part is this is non-recurring engineering, where the hosted solution is an ongoing tax, both in terms of cost and in terms of limitations. And really, do we need another web GUI? We have plenty of web GUIs. So, concluding. The hosted solutions solve important problems, but a very small range of them. All the big problems are still up to you. They're very handy for a quick start database solution, and in fact, that's the way a lot of companies get locked into it because they get their first round of funding, fire up a bunch of RDS services, and now they're stuck. But self-hosting is a completely viable solution. Don't assume that you must use a hosted solution to have a reliable database. Thanks very much. That concludes the talk. Here's my information. And now I believe it is time for questions.